Welcome to Unit 3, Day 1, which is Congruent Transformations. I'm sorry I couldn't be there with you guys today, but I should be back tomorrow. Just a recall from last unit, we talked about congruence transformations as usually one or more rigid motions, so translation, reflection, or rotation, that will get one figure to map perfectly on top of another. So we talk about the rigid motions being a translation, rotation, and reflection. Key thing here, make sure you change in your paper, is this so that it maps onto part. Okay, just be aware that if it says the image maps on the pre-image, we can change it to that as well. So you're going to need to insert. Okay, what is the pre-image? What vector or array are we going to be sliding along, and when do we stop so it maps onto what specific image? So when you rotate, you're going to do the same thing. Rotate what shape, along what which direction do you going to turn, around what point, and we're going to stop when it maps onto what specific figure. And reflection is kind of the same thing too. We're going to reflect what shape over what line, okay, and it's to map onto what image. Okay, now, if we're going to be describing in symbols, and we'll kind of get to this a little bit later, a translation uses a capital T, and then it uses two smaller, you'll see like what the ray is, so you might see like a little A and then B with the arrow over the top. So ray AB here is what the translation is. So it would be a big T, and then even smaller than this, you would see, this is called the subscript, written way down to the bottom there. That's what it would look like when you're done. So the same thing for rotation. So we would do a capital R for rotation, okay? And then we would put down the center in degrees. So what center is it? Now, if it's the origin, you might see a small 0, 0 written down here, okay? Or the word origin, and then the number of degrees. So are we rotating 90, 180, 270, or 360? And then a reflection is a lowercase r, and then you're going to do the line of reflection. So, for example, if we were reflecting over a line, you might write line segment AB here for yourself. And that's what that would look like. Okay? All right. So, we've talked about a little bit before how do we describe this in words. So, once again, and you can see the symbols, the rotation, center, common degrees, the reflection with the line of reflection, and then the translation along what vector there. So when you're describing in symbols, this is what it's going to look like. That means we're rotating this shape 120 degrees. That means we're going counterclockwise to the left to get there. All right. And we'd rotate triangle RQP around counterclockwise, or 120 degrees around point D. All right. Then we would take that shape, we'd reflect it over line EF, and then we would translate that triangle along ray V until it maps onto triangle Y, XYZ. And that's kind of how you would put that in words. So what we're going to be doing is describing these transformations in words today. All right. So if you take a look at example 1, we want to describe this transformation in words. So I'm just going to type it out. It'll be a little bit easier for me. And you guys can kind of write it down for yourself. So pause it here. All right. And see if you can think about what this is going to look like on your own here. Okay. So hopefully you described it as rotate. What are we rotating? Okay. So we don't want that. We want the triangle symbol. Right? Triangle, ABC, counter, clockwise. And you could say clockwise, it's up to you. All right, around point X. And when are we stopping? We're stopping so it maps onto, and then where's it going? Right? right? Triangle A prime, B prime, C prime. And that's it. Okay? So that would be the description that we have in words. All right. So we're going to complete the little spot below. So number one, when we took our triangle, okay, and because we did a rotation, remember, a rotation does not change the side lengths or the angle measures. So we know that triangle ABC is congruent all right, to triangle A prime, B prime, C prime. Sorry for the chicken scratch there. All right, it's congruent because, remember we just used, right, rotations, map point A to A prime, B to B prime, and C to C prime, and rigid motions map segments onto segments, and angles onto, you guessed it, angles. All right, so because we're not changing the length, the side length of the angle measure, we know that those triangles are going to overlap, the sides are going to be equal, and the angles will be equal. Therefore, the triangles will be equal. That's kind of how we'll describe that part in words. All right, what I'd like you to do is we're going to do, to these questions, we're going to describe in a rigid motion how we're getting triangle ABD to map onto CBD. Now, you got to be very particular about how these are labeled. So because we said ABD, okay, we know that A here is going to be congruent to C. So these two angles are going to be equal, okay? Likewise, we know that B is going to be congruent to D. So this angle here, which gets two arcs, is congruent to that angle here. And last, that angle B in this triangle, okay, is going to be equal to angle D in this triangle here, okay? So can we just do, is it going to be a simple thing as a reflection, right? If we reflect this over, are these angles going to overlap? That's kind of the idea of how we want to check to see what's going on here. And we can see that if we try to get these to just reflect over, that this angle right here, is actually congruent to this angle up here. That, if we reflect it and reflect it over, those aren't going to overlap. So instead, what we're going to have to do is we're going to have to turn it. Okay, now, what we don't have is we don't have a center point to turn it around. So we kind of have a problem here, all right, to get that to work. So think about what point could you create or could you discuss to get these to turn perfectly to land on each other. And really what you'd want to do is you'd want to figure out where the midpoint, right, of DB is, because wherever the middle is, when you spin around it, that's going to map perfectly onto one another. Okay? Now, we don't have to go about finding it. We can just describe, okay, describe that in words. And so what we're going to say is we're going to start by saying rotate. Now, it doesn't tell us what triangle to move, so we get to pick. So how about we'll just start with the first triangle on line here. We're going to say rotate, okay, triangle ABD around, remember we need a direction, so we can say clockwise this time, around, and because we don't have a point here, we don't know where this point is, and we're not going to create it. We're just going to talk about it. We'll say the midpoint of line segment DB, so of DB, okay? And remember, now that we've talked about we're rotating, we've discussed which direction, what we're going around, we just have to finish by saying when to stop. So we're going to say, so it maps onto, and what are we mapping onto? Triangle, and remember, we got to preserve the order. If we said ABD, we have to list these in the same order, so their corresponding angles and segments are listed in the same way. So if A was congruent to C, we have to say C next. B of here was congruent to, remember, angle D down there. And then this angle D was congruent to angle B over here, so we have to keep it as CDB. And that's it for letter A. All right. Take a look at letter B. All the smaller sized triangles are congruent to each other. What rigid motion maps line segment ZB on the line segment AZ? So here's line segment ZB. Okay. Oop, that's what we wanted, right? Why are you moving everywhere on me? All right, here's line segment ZB. Oh, we'll try that again later. All right. Right here, you can see that's ZB down here, and here's AZ. So how are we going to get ZB to map onto AZ? Well, pretty easy. Hopefully you guys can see it. We're going to need to, right, just slide that segment, okay, up, right, up that line there, that arrow, and we want to get that segment to go, this segment ZB to go right on top of that one, okay? That's going to be the goal here. Well, that's not what we wanted. All right, so if we can just get this segment, all right, and we just want to slide this segment up right along that ray, right along that line to get that map onto that one. So what did you slide it along, right? You just slid it along these two letters. The B goes on the Z, so we can say that we slid it along this ray, right, BZ. We could also say ZA. So it's totally up to you how you kind of want to put that down for ourselves. All right, so let's write this down. So we're going to say, now remember, we're doing a translation this time. So we're going to say translate. What are we translating? Okay, we're translating all right, line segment ZB. Oh, that's supposed to be a Z, right? All right. And then what are we translating along? So along, and we're going along that same ray here. Okay, so we're going to say ray ZB. All right. And then when do we stop? So it maps onto, right, line segment AZ. That's it. That's all we have to do. So what are we doing? We're translating. What segment are we translating? What ray are we moving it along? And when do I stop? I stop when this segment right here, ZB, gets on top of AZ. And that's it. That's all we have to do for a translation. Okay. Now the important thing, remember we talked about before, is being able to identify the corresponding parts of our figures. Okay? So we want to identify the corresponding vertices and then the corresponding sides. Now vertices are basically like angles in a way. Okay? So when we take a look at the first shape, we have triangle ABC. So we know that vertex A, when we start rotating this, and we can see when we rotate it, we're going to go 240 degrees. We're going to go in this direction. So point A is going to start here. It's going to rotate around, right? And when are we going to stop? We stop when it goes all the way up here, okay? All right. So A is going to travel up, and it's going to become X. All right. Where's C going to go? Or where's B going to go? So B is going to go onto, and C is going to go onto. Good. Hopefully put down B is going to go on to Y, right? And A and C is going to go on to Z. Now these angles, because we're doing a rigid motion, these vertices are going to create congruent angles. And those are the angles that they're congruent to. Likewise, right, this side AB, when you spin it around, is going to go onto this side, right, XY. And you can see that these two angles right here, A and B, and X and Y are written right after each other. So we know that AB, okay, is going to correspond to and be congruent to XY. All right. Likewise, this side AC, when we take it and we spin it, all right, is going to become, right, look at it, AC, look at the letters, XZ right here, okay? So we know that AC is going to be congruent to XZ. And then lastly, right, we also have side BC, which when we spin it is going to move on top of ZY. And you can see the order of the letters, BC and then ZY right there. So we know that BC, all right, is going to be congruent to YZ or ZY, your choice. All right, and that's it. So we want to describe the next thing in words. The transformation that shows the triangle ABC is congruent to triangle XYZ. That is essentially kind of saying the same thing. How do we get this triangle to map onto that one? So when it says explain the transformation that shows that they're congruent, it's the same thing it's onto. So what are we doing? Remember, this time we know we're going to do a rotation. So we're going to say rotate. Okay, remember, what are we rotating? We're rotating triangle ABC. Now, this time, because it told us 240 degrees, we can just say 240 degrees. We don't have to give a direction, per se, because it's implied with the 240 degrees. We still need to know what we're turning around. So around point P, and then so it maps onto what other triangle? And that's X, Y, Z. Okay? So when it gives you the degree measure, you don't need to tell me the what direction you're spinning. That's it. We just kind of have to give us the 240 and you're good to go. All right. If we're taking a look at the next question here, see if you can fill in, okay? Oh, and one more thing. Let's go back to the last question. It's explain why those triangles are congruent. All right? So if we're explaining why, and we want to put it in words, we can do that. Now remember, the key thing here is how do we know they're equal? Is to think about what did you do, right? What did you actually do to make them the same? Just change it. That's so it's better. All right, and we can say that a rotations are rigid motions and do not change side lengths or angle measures. All right, that would be enough to demonstrate why that they're congruent. And that's all you have to say for when you're describing why the transformation is going to have congruent shapes as a result. All right. In the next example, we have a square. AC is a diagonal in our square, and ABC is a reflection of ADC over segment AC. Complete the table below. Once again, if we're taking a look at our corresponding angles, okay, we have angle BAC, so we follow from B to AC. What is that equal to? Now, if it's a reflection, we should know that B is going to reflect over to D, but A is going to stay on itself because it's on the mirror, it's on the line, and so is C. So this is going to be angle DAC. All right, and that means AB, when we map it over and we flip it over that line, is going to go over here onto line segment AD. All right, the angle ABC where B is going to map onto the other letter, which is D, so that's going to be angle ADC. And that BC is going to map on like the mirror over here onto DC. All right, and then last but not least, that line AC is going to map onto itself. And that angle BCA is going to map onto angle DCA. All right. Okay, remember the question on the next one. Are those corresponding angles, sides and angles congruent? So justify your response. So we're going to say yes, right? Why are they congruent? Think about what did you do to get triangle ABC, right, to go on to triangle ADC, right? We reflected it. So because since reflections, okay, remember, do not change side lengths or angle measures. The triangles are congruent. Or we could say the sides and angles if you want. All right, and that would be enough to justify them being equal to each other. Okay? And then for the next one, are the two triangles congruent? Okay? And we can say the same thing here in a way. We can also say yes. Okay? So how do we know that they're equal? Since the sides and angles do not change sizes, the triangles are congruent. All right? Perfect. So what I'd like you to do, 2 more examples. So I want you to pause it for each one of these, and I want you to try them on your own. So this is where we're going to have, and we'll kind of do the first one together in a way. And then the second one I'll help you out with. See if you can try this number 3 here on your own here. See if you can come up with a sequence of rigid motions that's going to map this figure onto that one. And we're going to get there by going from 1 to 2 and then 2 to 3. Okay, if you didn't pause it, try to pause it now and see if you can describe that in words. All right, hopefully you looked at the first one and noticed that we are taking this figure and we are just translating it, and we are basically just getting, right, this point A to map onto that point A prime. All right, so hopefully you kind of saw that for yourself, that this point is going onto that point. I'm trying to get this to draw. It's not working very well. There we go. All right. You could also say that about any of these, right? We could say that we're moving E to E prime, D to D prime, whatever point we want to move. We just need 2 corresponding points here for this to work, okay? So as long as you pick 2 corresponding points and you use them as your ray, that will be correct. So we'll do A to A prime since we kind of started there. So we're going to say first, because we're talking about a sequence, so we need an order, okay? Translate A, B, C, D, E, F along, and remember we're doing array, so it's A prime, all right, remember what we're doing, we're moving it along A prime, so we start with a figure, we know the array we're moving it along. When do we stop moving it? So it maps onto, and where is it going? A prime, B prime, C prime, D prime, E prime, F prime. So that's the first move. Okay, then what are we doing? Now look at the order of your points. It's pretty obvious, hopefully, you can see that all you're doing is just turning the shape, right? So we're rotating, and the point we're rotating around is that point Z right there. So we're going to say then rotate. Now remember, we've already moved our figure, so now we're going to say A prime, B prime, C prime, D prime, E prime, F prime. We need a direction. We don't have an angle measure, so we can say clockwise around point Z, And remember, when do we stop turning? So it maps onto, and what are we going on to? Our final figure, our final form here, which is A double prime, B double prime, C double prime, D double prime, E double prime, F double prime. And that's it, we're done. All right. So let's see, and this is one we're going to do together here for number 4, and then I'll have you try these two for homework on your own. All right. Okay, so for number 4, what we're going to want to do is we're going to want to think about how do we get this triangle to go onto this triangle. And what we really want to do for ourselves is kind of think about how do we get them to kind of overlap first. So when the triangles are not facing in the same way, you can see like this one, these two figures, right, where you could tell you just slid one over and it mapped onto the other one. Here, that's not the case, okay? So what I need to do is get something to overlap first. Then I can just turn one of the shapes and then it'll map onto the other one. So as long as they're overlapping, okay, then we know we can just take one and turn it. So here's what we're going to do. Let's consider for number 4, all right, this triangle ABC. If I can just take this triangle and slide it over, so one of the corresponding points is going to overlap. So I want to slide it, let's say, until point D here maps on to point F, okay? And then from here, all I'll need to do, I don't know if we can do this with this one, that's right, is just turn it, right? Turn it around point F. Now, imagine that once point F is here, when we spin it around, okay, around point F, obviously I'm not turning around point F there, all right, as we get closer and closer here, it'll eventually just map right onto that. They're already the same size, so what we're going to do, right, is we're going to get these two to line up, okay, with one of the corresponding points, and then we can just turn it clockwise or counterclockwise until it goes onto the other shape. That's it. So that's the strategy. So translate first, okay, get two corresponding points to overlap, and then turn to get the shape onto itself. All right, so here's what it's going to look like. We're going to say, first, translate. What are we moving? Now this one says to map ABC onto DEF, so it's giving us the direction. It's giving us, tells us what to move. Triangle ABC along what ray? Now we said that we want C to map onto F. So that means we're going to do, okay, ray CF. Oh, I got rid of it for us. That's okay. We can do a little accent here. We need a ray. All right. Now remember, we've translated it. We're moving it along that ray. When do we stop moving it? So now be careful. The triangles aren't going to overlap. So we're going to say, so point C maps onto point F, okay? Or we could just say, so C maps onto F, all right? So instead of having the whole triangle overlap, we're just going to stop when C gets on top of F. All right, then what do we do? Then we're going to rotate. What are we rotating? Okay. Now remember, this triangle has moved over here, so we're still rotating the same triangle. Triangle ABC. All right. Which direction? So we'll go counter clockwise this time. All right. What are we spinning around? Remember, where are the two triangles? What are they sharing? They share point F. Okay, around F. And then when do I stop? So it maps onto triangle DEF. Okay? So, just a quick recap. We took our triangle here. All right. ABC. All right. We translated it along this ray, CF. So we got this to move over to here. All right. So C mapped onto F. And then we rotated it counterclockwise or clockwise, your choice. And remember what we wanted to have happen. We were going to spin around this point F, right, until we got these to map onto one another. And then we would stop, okay? So sliding it until they overlap, spinning it around that point until we get them to, the whole triangles to overlap. Now, point of order, if you wanted to do the rotation first, okay, when would you stop rotating, right? Remember, what I need to do after I rotate is then translate so they're perfectly mapped up. So when we're going to stop rotating is when I can get two of these corresponding sides to be parallel. Then when I slide this over, well, not that one. Then when I slide this over, if they are parallel, okay, if they are parallel, get out of here, you. All right, we're breaking things. If they are parallel, yeah, we're done with this. All right, then those are going to, triangles will map up perfectly. So if you did it in the other order, say rotate like clockwise or counterclockwise around one of the points so that two lines are parallel, two corresponding sides, and then translate so we get one onto the other. All right, for homework tonight, I want you to do these two questions the same way we just did number 3, and we'll talk about them tomorrow. Hope you guys have a great rest of your day, and we'll see you guys tomorrow.